Lesson 9.1, Matrices and Systems of Equations. A matrix is a rectangular array of numbers. You can write it like this symbolically, where the first number is its row. Rows go this way. And the second number is the column. So each entry is a letter and then row, column. We call these entries an element. So each element has a row and column. Rows go sideways, columns go up and down. An augmented matrix are two matrices combined together. And we usually put a little colons between the matrices to show where they were combined. Here, these ellipses just show that the pattern continues and is much larger, that we skip some numbers. An order of a matrix, also known as its dimension, is the number of rows by the number of columns. So what is the order of this matrix? Well, rows go sideways, so there are two rows. There are three columns. Now you remember, columns go up and down because if we have a building, have these things that hold up the roof, those things that hold up the roof are called columns. We have three columns. So it is a 2 by 3 matrix. Elementary row operations are used to deal with matrices. We already had these when we're doing systems of equations. So let's review. We can interchange two rows where each row would represent like an equation. You can multiply a row by a non-zero number. And you can add a multiple of one row to another row, replacing the second row. So let's try some elementary row operations. Let's add 2 times the first row to the second row. So we're going to multiply the first one by 2, and we're going to add it to the second row. Since we're adding it to the second row, the first row doesn't actually change. So we have 2 times 1 plus 4. 2 times 2 plus 5. 2 times 3 plus 6. So you just do the operation and put it in the second row. And you might remember row-echelon form. For a matrix, all rows that are entirely zeros are at the bottom. For all the other rows, the first non-zero entry is 1. So it has to start with a 1 or 0 and then a 1. For successive rows, the leading one in the higher row is further to the left. That makes kind of an inverted pyramid shape. So the row of all zeros is at the bottom. The other rows start at 1. Start with a 1 if it's not a 0. And it makes this upside down kind of triangle shape. For the second one, the first thing that's not a 0 is a 1. And you can see the 1s move off towards the right as they go down, making this inverted triangle. Reduced row echelon form goes a step further. Columns with leading ones also have zeros as the other entries. So this is a leading 1, so that means this 3 above it should be a 0. That's a leading 1, which means the 2 and the 4 above them should be zeros. So if it was in reduced row echelon form, it would look like that. All right, let's solve the system of equations. But let's do it by using a matrix. So the first thing is let's make a matrix with all the coefficients. And where the equal signs, let's put it like a colon. And then we're going to put this into row echelon form. So the first equation starts with a 1. So our first step is let's make the first entry on the second row as 0. So we need to get rid of that 2. So we could multiply the first row by 2 and add it to the second row. That means the first row stays the same and the third row stays the same, but the second row changes. So it's negative 2 times 1 plus 2 is 0. Negative 2 times 3 plus 7 is 1. Negative 2 times 4 is negative 8, plus 5 is negative 3. Negative 2 times 7 is negative 14, plus 10 is negative 4. All right, for our next step, let's get a 0 for the next row, the third row. So we can multiply the first equation by negative 1 or negative 3 and add it to the third row. Since I'm adding to the third row, the first row and the second row stay the same. Third row becomes negative 3 times 1 plus 3. Negative 3 times 3 plus 10. Negative 3 times 4 plus 4. And negative 3 times 7 plus 7. All right, so now we have zeros in our first column. Now let's get zeros in our second column. We need to get a 0 below the leading 1, so that needs to be a 0. And we can get that by multiplying, let's say, the second equation, second row, by negative 1 and adding it to the third. That would mean the first row stays the same. Second row stays the same because I only want to change the third row. So we had negative 1 times 0 plus 0 is 0. That's why we had to add the second and third row. If we added the first and third row, we would have had something in the first spot there. Negative 1 times 1 plus 1. Negative 1 times negative 3 is 3. Plus negative 8 is negative 5. And negative 1 times negative 4 plus 6 is 10. All right, we're almost in row echelon form. This leading number there needs to be a 1. So let's multiply the third row by negative 1/5. My first row already starts with a 1, so it's good. The second row starts with a 1, so it's good. Third row now would be negative 1/5 times 0, negative 1/5 times 0, negative 1/5 times negative 5, and negative 1/5 times 10. So how does that help us? Well, remember this was x, y, and z. So from our third row, I get 1z equals negative 2. So then I can use the second row, which is 1y minus 3z equals negative 4. Well, z was negative 2. And it looks like y then would be negative 10. And then we can take our first row and plug in y and z. So it's 1x plus 3y plus 4z equals 7. So it would be x minus 30 minus 8. So it looks like, if I add those, so they're on the other side, x will be 45. So our answer is 45, negative 10, negative 2. And of course, the best thing to do now is to plug that into each of the equations and make sure it actually works. It does.